This is a demonstration video of the Forrest Manufacturing Model 480i horizontal blade bandsaw with a vacuum cup table. I have other videos explaining all the features of the Model 480i, so I'll just give you the short version here. This is a horizontal blade bandsaw cutting in a horizontal plane. The head height, or the blade height, is adjustable with a hand crank, electronic digital readout showing you the height, but it's meant for set it and meant to set the height and make multiple cuts of the same height. It's not really as good at making, say, a lot of sheets off a single block where you have to move the head between every cut. You can do that if you're value conscious. The table is a traveling table, a variable speed, automatic stop. This machine is controlled with our basic controls. So we have saw start, stop, pneumatic blade tensioning and detensioning, indicators for motor fault or blade fault. Blade fault can be either a broken blade, insufficient air pressure for the pneumatic blade tensioning system. Table controls. We have table forward and reverse, plus table stop. We have separate speed controls for the forward and reverse directions. The idea being, when you're making a cut, you'll cut it, if we set it up right, you'll be cutting at something like 20% of the full speed. And then when you are done making a cut and want to return the table to the home position, you don't want to wait, so you just set 100% and leave it there. So you'll set the forward speed, you'll find some speed you like and just leave it there. Return speed is pretty much going to live its life at 100%. That's standard Model 480. Where this gets more interesting is this machine has a basic table under here, and it has these lift-off panels covered with suction cups. So we've got 4 panels. Each one can be turned on and off individually. Each panel in turn on the underside has 4 vacuum pumps. I'm going to do a separate video to illustrate all the details of construction because most of you probably don't want to listen to all that. But the short version is each panel has 4 separate suction pumps. Each pump controls 6 suction cups, and they are interlaced, interspersed across the table surface, such that if you have one spring a leak, you don't lose vacuum to the whole system. And then you can turn on or off the panels as you want. The air pumps are mounted underneath here, and they are powered by compressed air. It uses a Bernoulli effect vacuum pump, turns compressed air into vacuum. Science is really just another word for magic. On the control panel here, we have added buttons for each of the panels, so you can turn on or off each panel independently, more or less, depending on use. Use all the suction cups you need, but the pumps do consume compressed air. So if you're running all the pumps, you're using more compressed air, just run what you need. So with the pumps running, and since this is a demo, I'm gonna run them all. Each of these cups here has a little button in the middle. So they're not doing anything until you press the button. I don't know if the microphone can pick that up. Press the button and it pulls vacuum. So you're not wasting vacuum. So if I have a workpiece of any shape, I can throw it on the table. The cups it is touching will pull down. The cups it is not touching will stay sealed off, so you're not wasting vacuum. A more traditional vacuum table might be to have a table that looks like this, and the whole top will be covered with little holes, and you'll pull a vacuum on the chamber. So the table would be basically a box with only the holes on top, and it might be a vacuum lever on bottom. You'll pull vacuum in the chamber, and all these holes are vacuum sources. It's kind of like the reverse of an air hockey table. The problem with that is, if even just one of those holes is not covered, then you don't have vacuum across the whole table. This isolates it, so I can throw pretty much any shaped workpiece up here, and it will grab. So I have a workpiece to demonstrate with. Now, industry pros are going to be insulted. I don't know the difference between thermoforming and vacuum forming. This is one of those. This workpiece was sent in by a customer. This saw was built for another customer I have a customer who has some of these saws. They have a slightly different configuration, but the idea is the same. So we want to cut the form shapes off of this parent sheet. To do that, I'm just going to set this on the table like that, and the cups that it's touching are pulling, and the cups that it's not are still pulling vacuum, or are still sealed out. So you can pretty much throw any workpiece up here and grab a hold of it. I haven't really set the blade up yet. I'm going to go ahead and advance the table up to the workpiece. Yeah, that'll be fine. And as I said, I have not cut the particular workpiece on this saw, so there'll be a little experimentation. I'm going to start off at a very low speed and then increase speed as I feel I can get away with it. My philosophy here is before I can sell any bandsaws, I have to get a good quality cut. Once I have a good quality cut, then I can worry about speed. But if I can't cut the mustard or the plastic piece, then I'm not going to sell any bandsaws. I'll zoom in a little for you here. Okay, I'm going to start the table. I'm going to start at speed 0. Actually, got myself out of order there. I got to start the saw. There we go. I'll set the table forward speed at 0, hit the forward speed, hit the forward button, and advance the workpiece into the saw blade. And I'm going to start off very slowly and then accelerate here as I'm sure things are working out. Looks like I can run it faster than that. This is probably a little bit coarser blade than I should use for this workpiece. This is about a 6 tooth per inch blade. I could probably, for this material, I could probably use like a 16 or even 20 tooth per inch blade to get a smoother cut action. I'm not going to cut through all the way through both pieces. I'll just cut the first two to show you what's going on. Okay, we'll stop it there. Can I get one of those, please? Thank you. Look at that. Pretty nifty. Compare that to having a human operator manually trim that with like a pair of scissors or a skill saw or something. This is, if you're putting multiple sheets on, or multiple pieces on a single sheet, this is certainly faster. And I'm going to say that's a better quality cut than a manual operator is going to get. A little bit of furring, that's mostly down to my using a fairly coarse bandsaw blade. But that's what the machine does. That's a Model Forest, Model 480i with a vacuum cup table. If you have any questions, please feel free to call or email us at Forest Manufacturing. Thank you.